Okay. I did feel sorry for you at one point in my life, before you got on my nerves. I did feel sorry for you.
I'm so exhausted.
Did sort of feel sorry for you. It's passing every minute. On that worksheet from last week, because it was very difficult. So we're just going to put a pin in it for now. It's not going to be due. I'm just going to take off when it's due. It would be great if you could get stuff done on it, but we're going to take off, and if you want yours back to adjust things in your life. In fact, let me get that back in case you want to adjust things as we go. I understand. There's a lot of stuff that we haven't used words on that you might need words said. Okay, that's my bad. We didn't get as far as I thought we would, and then I had to be out, so that is my bad. So it's not due immediately. There was a second worksheet, some picked up, some didn't. I'm going to put it back on the podium. It would be smart if you start that one. It's way easier.
The linear regression.
Yeah, it's a different linear regression way. It's way easier. And why is it way easier? And I'll show you why now. Okay. I posted something for you, Sally. If you didn't see it, I'll show you how at the end of class.
What was? Oh, the calculator.
Yeah.
I haven't looked at it.
Okay. Well, if not, I'll show you at the end of class. It's really easy. It's like 2 extra button pushes, just because yours is a generation older. It's not a big deal. Okay. So the other worksheet would be easier for you to handle because you get to put this data into your calculator. You get to make the scatter plot. You get to make that ladder regression. So it's not like they're giving it to you. You get to control all the things. So I think this worksheet would be way easier for you to handle. If you wanted to put the other one away and start this one whenever we have a free chance, that's what I would do. Because this one's easier because you get to input it. It's not given to you like, here, deal with it. It's you get to input it. Okay. We were saying words yesterday, and then the words got stopped. So let's back up to page 5 of your notes. Page 5. Huh?
Yes.
Yes. Okay, so we have been talking about scatter plots, explanatory variables, response variables, fitting a line to this data. We call this line the line of best fit. We love it when our calculator does it for us. We're confused when we're given a table by someone else with the calculator stuff on it because that's just confusing as math. But we have to actually note, and I said this the other day and I'm going to say it again, what's really annoying is that you and I prefer mx plus b, but they put it in a different order. They put the slope second. They put the intercept first. And you're like, Ms. Compton, why do I need to know that? It matters because you have to know that B0 is the intercept. You have to know that B1 or B0 is the intercept. You have to know that B1 is the slope. Why do you have to know that? They could potentially ask you a question asking you to calculate the slope or the intercept. So you would have to know, and they're not going to say the word intercept. They're going to say B0. So the good news is if you've looked at your formula sheet, this formula is on your formula sheet. So if Louise has a blonde moment, which we all do, it's fine. He could look at the formula sheet and be like, oh yeah, B0 is supposed to be the intercept. Here's the formula for that. B1 is supposed to be the slope. Here's the formula for that. So if you forget, that's fine. It's on your formula sheet. So I would say if I was writing my formula sheet like we did yesterday, that these 3 formulas all have to deal with the least squares regression line.
Question.
Yes, dear.
Why do we ever need to use this formula if we're given points? We don't just plug those in our calculator and then calculate that way.
Like this, well, it says it in the notes. So on the AP test, you may be asked to manipulate these equations algebraically to solve for an unknown. So they might give you the slope, or they might give you y bar. Like here, we went over an example like this last week, but I'm with you, and it's been a while. They might give you y bar. They might give you x bar. Maybe they give you B0 and ask you to solve for B1. Or so they might give you missing pieces, and you have to solve. Just like how we had to with the backwards z-scores, how we ended up having to solve an equation backwards to get x bar or x. Yeah, okay. So we might have to solve something backwards. There's potential for a multiple choice question where you need to know this. Otherwise, I'm with you. Doesn't seem important. Okay, so moving on. So this is where we were stuck yesterday. This is where a lot of people were messing up on their worksheets. So this is why I wanted to come back and start here today. Interpreting y-intercept and slope. Okay. We've been over and over and over that the most important part of this class is to relate it back to the context. So yesterday when we were looking at, I think it was 3 point something was our slope, then we have to relate it back to that was calories. Or the intercept was at, I don't remember what the number was, but what that meant in terms of the problem. So we have to relate it back to the context of the problem. And it helps if you use that explanatory and response variable. So with your worksheet from yesterday, do you have your worksheet from yesterday to make my life easier since I'm talking about fictitious stuff? Alex, do you have yours?
What does it look like? Is it
A worksheet? Bless you. Thank you. The one with the calculator charts on it. That's why it's annoying. So Alex has his. So on the worksheet from yesterday, there was a question that asked you to interpret the slope and the y-intercept of the regression line in context. So we decided that we had found the slope and we had found that intercept, but Alex has to do it in context. So he's got to say 560.65 calories. He's got to say negative 3.0771 calories per, is it time in minutes, so calories per minute. So he's got to interpret it in terms of the problem. Because if we're not relating it back to the context, then really what was the point in finding it? Thank you, dear. That's really it. Thank you. Thank you for the correction one. Okay, so we talked about that. Go to the next page. And Olivia will be happy because we're going to get to practice some of the things. So back to that SEC data from forever ago, which no is no longer in my calculator either. That SEC data from forever ago, they've written us an equation. They want to know the value of the y-intercept and interpret the y-intercept in context. So what is the y-intercept in this equation?
Negative 3.75.
Okay, negative 3.75. But I need to interpret that in terms of the problem. What does that mean in terms of the problem?
They want negative 0.375 times the time.
I thought, so we had a graph the other day, and I can pull it back up, where we had points per game and wins, and everything was great. How did they get a negative slope when we decided there was a positive? It was not a negative slope, it was a negative intercept. Oh, okay, never mind. That's stupid. Okay, Louise wanted to say, let me refresh your memory. This is the situation we were talking about. Wins, points per game, SEC football. Louise wanted to say the reason this intercept is at negative 3.75 is why?
No idea. I was kind of saying something.
You said something about time. But is time in this problem? No. So I need to say what?
It's if you get 0 points, you end up losing 3 3/4 more games than you would have won otherwise.
Yeah, that's what I would probably say. So if we won 0 games, well, if we scored 0 points per game, we lost almost 4 games that season. So I'm with you, and I'd like to relate everything back to time, but those weren't our explanatory and response variables. So we've got to relate it back to wins and points per game only. So negative 3.75. If my team scores 0 points per game, I should have spelled out points and I didn't. If my team scores 0 points per game, we probably lose. Almost 4 more games that season. And that makes sense. Your team sucks. You're not scoring any points. You lose more.
Why 4 games though?
I just rounded up 3.75 to 4. I just went to the nearest whole number.
Why is that true though?
-4. Well, if I'm rounding and it's 3.75, I don't want to round down to 3, so I rounded up to -4.
Yeah, I know. Yeah, but why would you lose 4 games if you got 0 points?
Well, you don't.
4 more games than you were expected to.
The negative 3.75 is the win. So it would be.
Your wins are decreasing because your points are even low because your points are at 0.
Okay, gotcha.
Oh, it's dumb. I'm not. The intercept tends to be very dumb, because is that realistic? That we scored 0 points every game? No. I mean, surely we can pull off a miracle and score at least something. Well, unless you're Vanderbilt, and then you couldn't. But you did another game. Like, they didn't score 1 game, so what? They're going to score in the next game. So Y intercept is not always feasible in real life. But we still have to relate it in terms of the context of that given problem. Okay, and then it says, what is the value of the slope? So what's the slope in that equation? 0.44. And what does that slope tell us?
But there's
How many points per game you
That's-
score?
that's how many wins you get per point. Per score?
Okay, so slope is what over what in real
Rise
life?
over run.
Okay, but we're in stats, so we decided rise over 1. I know that's y's over x's or whatever. I get that, but we had explanatory and response. Which one's explanatory, which one's response?
Explanatory is the
Yeah.
points.
Explanatory is the X.
We said explanatory was the x. We said that response was the y. So, response depends on something, so response is the y, and it needs to be in the numerator. So this is really response over explanatory. Which one was the response variable in our scenario that we're talking about? Was it points or wins? Wins. It was wins over points per game. So interpret the meaning of the slope in the context. It's 0.44. So we would say wins over per. I lost my train of thought. That's bad. Slope is rise over win.
Do the number of points, number of wins, depending number of points.
As each point increases, you would think the wins increases by 0.44. So, since wins over points per game, so it's like 0.44 over 1 is how me and Louise are interpreting it, which is what makes the most sense in life. So, we 0.44 increase to win by simply adding 1 point per game.
What do you mean 0.44 increase? That doesn't make any sense.
No, it doesn't. I don't like the wording. I don't like the wording of that either. Okay, so value of the slope, we decided was 0.44. Interpret the slope in the context. It was a positive slope, so as our points increase, our chance of a win increased. We understood that already, though.
Is that not how you can interpret the slope?
But this isn't measuring probability, it's measuring the number of wins though.
Yes, I agree. No, I agree. But give me some wording.
I don't know, maybe it's like, maybe you could put an interest probability, like since it's a positive slope, the number of increase of points leads to a higher probability of winning. There's no,
That's
it's
not about
positive, the positive correlated, you know.
And I guess we'll just keep it simple the way me and Sally were. Higher chance of winning as points per game increases. I mean, who said we had to be very literal, good Lord, literal and say exactly the 0.44? Why can't we just say generically, since it's positive, this is what's happening? The larger the positive number, the larger the increase, yes. Maybe we could say something smart like that. But since we're having a blind moment, and God knows those are allowed, as long as we signify that there's positive and positive, we're fine. Okay, moving on. Number 3. Suppose that in 2011, the SEC was contemplating adding a 13th team to their conference that averaged 21.2 points per game. Predict the number of wins that this team would have based on the equation of the regression line. here is why we would need to understand that equation. So we were given this equation, wins equals negative 3.75 plus 0.44, and then it was points per game. They want to know how many wins we would have if the team averages 21.2. So we're literally going to plug stuff in. We're trying to figure out wins. We know the points per game is 21.2.
Since it's predict, do we have to calculate that?
So we're literally going to calculate. When it says predict, so we're using that regression line to make a good guess. So we're plugging it into that regression line to make a good guess. So I am going to actually calculate this. So 0.44 times 21.2 minus 3.75. I get 5.578.
Should be a whole number though.
And shouldn't that be a whole number? Because you can't have 5.578 to a win. So how many wins would we predict?
6.
Or I shouldn't say we, but I will. We predict 6 wins. Or we could say it better than this. We could say, using this equation, there are going to estimated of 6 wins for the season.
Would it be okay to run the points too in the equation?
I probably wouldn't round to the very end, just because if you round in the middle, so she's wanting to round here up to 4.
No, I'm talking about the 21.2.
Okay, so if we round the 21.2 to 21, what are you rounding the 0.44 to?
Oh, okay, right. That's just
So then we start rounding everybody,
yeah, that's okay.
and then, I don't know, it gets real fishy. I don't round stuff till the end. It's not a bad idea, but I don't round stuff till the end. Okay. Are you better with that? That's why we're doing this whole equation. And that way we could estimate in the future what would happen. Like if we added a next team, what would their estimated wins be?
I feel like if we weren't doing this problem, I wouldn't have been able to start on this.
Okay, so again, on that awful worksheet where it's like a picture of what's on your calculator screen, we're having to interpret that. I get it. But on this other worksheet, it's like typing this stuff on the scatter plot, make your own regression line, interpret that regression line, the B and the M of that regression line, so the intercept and the slope, and then like estimate new stuff after that. The way we had to estimate if there was a different team and this was their average, how many wins would they have? I swear it's not easy. I don't know how I made life this complicated. I don't know what happened, but I swear this is an easy chapter. Okay. It's just too many words. Yeah. It's too many vocab terms all at once. Okay. So, now Olivia's going to be happier because we get someone that looks like a computer handout. And I can't read. So, can someone, for the love, read the example,
I got you.
please?
For their second semester project, 2 AP statistics students decided to investigate the effect of sugar on the life of cut flowers. They went to the local grocery store and randomly selected 12 carnations. All the carnations seemed equally healthy when they were selected. When they got home, the students prepared 12 identical vases and exactly the same amount of water in each vase. They put 1 tablespoon of sugar in 3 vases. Listen here.
Does this seem realistic at all? That's why she's laughing. This
No, I
is
like
ridiculous.
this big
2
boss.
tablespoons of sugar and 3
Oh.
vases.
I like bars. It sounded so expensive.
And 3 tablespoons of sugar in 3 vases.
Oh, no, you do it so
Maybe 3
nasally.
vases.
No.
But no sugar.
You do
After
it
the
so
vase-
nasally. No.
Boss.
After the vases were prepared and placed in the same location, the students randomly assigned 1 flower to each vase and observed how many hours each flower continued to look fresh. A computer output of the regression is shown. What is the equation of the least square line regression line in context? Interpret the slope of the y-intercept, interpret the slope and the y-intercept in context. Find and comment on the value of the correlation coefficient. Author.
What kind of situations are there? There's so many more.
There were so many words. So let's just one step at a time. So Olivia's already wanting to tune out. She's already mad because it's got this little chart that looks like calculus bottoming in. But there's good news and bad news. We're going to clarify some stuff on this chart. There's a lot of this stuff that we don't need. R squared adjusted is not for us. I was telling the Louise about that yesterday. Adjusted means they're like taking out some of the data points. Maybe they've determined something's an outlier and they're getting rid of it. We're not looking at that. We're taking the data as it is. So we only want R squared. So they asked us to calculate R. Yes. We want R squared. So we do want, it asks us to find the correlation coefficient, which is R, and I had someone put a question mark on that on their paper, so they're breaking my heart. So we can find that correlation coefficient. Yes, ma'am.
Like 0.9. Sorry.
I was gonna
You.
why do they square it?
We're going to get to that in just a few minutes, but they tend to give you R squared because R squared is always positive, and then they turn it into a percentage, and it just looks so pretty that way. Because if they give you R, then they're telling you everything. So they're telling you positive. Well, I got my hands up backwards because they're telling you positive or negative association when they're telling you a positive or negative R automatically. They tell you R squared. You have to decide positive or negative association. So it's really smart on their end. Okay, so they gave you R squared, not R. We need to find R. We talked about the other day, you have to take the square root of R squared. But as Louise pointed out, you have to turn it into a decimal first instead of a percentage. So we need to do the square root of 0.86. And Sally's right, we did it the other day. She wrote it down apparently. I don't know.
It's like 0.9274.
Okay, so and we're going to round to 2 decimal places, so I'm going to say 0.93. It was 927, and I'm just going to say 0.93. Is that a good value for R?
Yes.
What does that mean?
Strong correlation.
It has a strong association because it's 0.93.
0.5?
Because it's above what number means you can say, if it's above 0.8, you can say strong. If it's 0.5 to 0.8, what word should you use?
Moderate.
Moderate. And if it's got less than 0.5, you should say, I don't think it has any, or you could say weak. Okay, so this is a good number, and this 0.93 is a good sign. We're really excited about that. That's a good number. And as they put, if we were having to use our little DOFS acronym, we would say, we said that the other day, we would say it has a strong association. So the explanatory response variable, which I guess we need to get into in just a second, have a strong association.
Wait, so this helps me.
Yes, you.
If there was like, if someone did research and found out something causes something else, would it be 1? Would their association be 1?
They are probably not, and I would want to look at their data because I feel like they did something wrong, and I feel like they did something wrong. I feel like you can be like 0.99 and be real close, but I feel like if you're one that's saying it's a perfect thing, and for sure, like there's always another factor. There's always other stuff in life. It should never be exactly 1, I would think. No. I would be very suspicious of that research study. Ma'am.
I don't know if that's positive or negative. Or
We don't.
Do we need to write it as positive or negative right now, or just?
Oh, we're going to come back. We might come back and add in a little quick negative sign. She's right. We don't know at this minute if it's positive or negative. We need to see that slope to see if it's positive or negative first. And that's back to Shalia's question of why do they give you R squared? Because they're smart. Now you have to decide if R is positive or negative. They have just given you R. They'd be giving away all the ducks in their basket or whatever.
So if it was negative or not, you can't say strong association.
You would say it's a strong negative association. I would add in the word negative or positive. I might say strong positive association or strong negative association, but I got to figure out what sign before I start throwing in that word.
So don't do that to after.
Yeah, I would wait. I would wait till I thought things through. Okay, so we did find that correlation coefficient, but sadly there were a lot of other things we were supposed to do. They asked us to interpret the slope and the y-intercept, but my gosh, why should we interpret anything until we write an equation of the least squares line in the context? So we're going to need an equation, and you and I are so used to y equals mx plus b, so I'm going to put it in that form. I'm going to need, let's see, and the book had it as b0 plus b1x. Again, I'm still in this junk straight from your formula sheet. I know you and I would rather do a different order, but this is how they do it.
Thing about the 1.
Why hat? It's just my way of keeping straight that it's not the same as the y-intercept. It's my way of denoting that it's not the y-intercept, or I start getting confused. No, not right now. Eventually it'll be important to us, but right now, no. It's just It just helps me not get confused in my life. Okay, before we let Louise guess, there's some other good news that's going to make Olivia happy. So if you're given a weirdo calculator chart like this, there's some other information up there that we seriously don't need. Well, we don't need for now. So the T and the P column, we don't need them.
No.
We don't need them for what we're doing.
T stands for potato.
Toilet paper.
No.
Here's
T-
the number.
T and P are coming, these won't even be discussed until second semester. This involves hypothesis testing.
Is that Pearson's correlation coefficient?
He is out of my league.
Dang.
Hypothesis testing is where I almost wanted to cry at training. I'm going to get it together before I have to tell y'all about it. It didn't seem that hard. It just seemed like, oh my God, it's been a long time since I've had stats. Not that it's hard, it was just hadn't been there. So anyway, this isn't even until second semester. So if you want to ignore the entire T and P column, totally understand. You don't need them. Yeah, second sem for second semester.
Yes.
Okay, so now we've got either we want the coefficient column, or we want the, I'm guessing SE is for standard error coefficient. Which one makes sense? Coefficient column makes sense to me as well. If I didn't know, just bring the colors over there. Why not? That would make life so much easier. Okay, so we need to know the intercept. Do you think it's going to be the constant or the sugar?
Constant.
It sure would help if we had a table. My gosh, Miss Compton is so mean. So I guess I should show you what's in my notes. Maybe that would help. If we're looking at this table, because look, haha, I have it graphed. So is the y-intercept going to be the sugar or the constant? It's going to be the constant. And what number does my graph look like it hits?
One like 70 something.
Yeah, like a little below 180. And then what number is next to you in constant?
181.
Okay, so my graph's a little off, God forbid. The calculator says it's 181.200. So now we found this is the intercept. We've got it. There's that y-intercept.
That number going to be the y-intercept every time?
Yes.
And
Every time.
without fail.
Without fail. So, and the other one's going to be the slope. And then something fell. That's fine. It is normally, on all the ones that I've seen, it's been called constant. But I don't want to say always to anything McKenzie, because I don't know.
So we'll always be right there, top left.
Extremely tight.
This?
Yeah, we'll always be right there.
Yeah.
Wait, so what is SE code?
The standard error coefficient. We don't need that. That's telling us how off things are. I'm not saying we're not going to come back to this eventually, but just to write the equation of the line, here's the intercept, here's the slope. That's what we need to know. So this number is the slope. So our equation should be like y equals, or y hat, if you're trying to be fancy like me, y hat equals 181.2 plus 15.2x. Okay. Be real with me. So anyone who's lost here,
I actually think I got it.
Is the carrot symbol actually
Now that I
all it
can
has?
read the freaking chart, I think I'll be good.
when we say it out loud, we say y hat, yes.
Y hat?
But then with y with a line on top, you don't say y line, you say y bar. So who named this junk? I don't
Y
know.
hat?
Seriously, you say y hat.
I only know it as the house symbol. The little house thingy in Sam.
It's an accent.
Yeah.
Accent.
One.
In stats, we use it just to help us keep track, because otherwise when you say y, so Sally asked a good question and I didn't really explain it, so I need to explain it now, because that's a good question. So why I put y hat rather than y. So, and I guess I should even put like x hat or something too. It helps me to know, yes, I'm not talking about the explanatory, like it helps me to know this is different from the y-axis, this is different. It helps me keep track of who's what. Y hat helps me know I'm talking specifically about my equation. So you just want to put y equals for now. It's going to be fine. Your textbook's going to note it with a y hat. Eventually you'll start to note it with a y hat. I don't know. Eventually if enough people do something, eventually you catch on. I don't know.
Wait, so you don't know the explanatory responsibility from the equation?
We knew them from the paragraph we read as to who they were.
So which one of these numbers are explanatory? Like, or what do they represent?
Well, see, I get lost on the
It's
explanatory.
y-intercept and slope.
Whatever it is.
Okay, right now we have y-intercept and slope, and neither one of those are explanatory or response. Although one of the variables was specified in the table. That's true. Which variable was specified in the table? Sugar. What's the other variable we're talking about?
Constant.
It says constant, but
That's not a variable.
It's not a variable.
Sorry.
Explanatory response variable. So one of them is sugar, yes, and that's going to be the explanatory. And yes, the explanatory is always the one next to that number, yes. This one is talking about the response one, but the response one if we want to define it, what is the response variable?
Yeah.
What is that?
I guess the amount of death in the flowers.
The amount of death. The level of death.
Percentage death.
How can they even measure how that looks like?
Well, if they're dead.
Okay, it tells you in the second to last sentence what the other variable is. It did not say amount of death. In the second to last sentence, they tell you. They observed what?
But it's not that dead.
What did they observe?
It has a little
The hours each flower.
So the response variable is about the freshness in hours.
Whoa, wait, what does it look like? That's
Hours of
subjective.
freshness. Yeah, that's not a very good variable there.
Oh, this is not a very good study at
No,
all.
it's really not.
With water and stuff, it was not a very good experiment at all.
With
It's
water?
based off of how the
Wait,
flowers
what?
would look, how long they would look.
No, each person was supposed to measure a specific amount to put it. So 12 different people had to do different things where they put, I'm supposed to trust you to put the right amount of water, and we're all going to put the same amount of water.
I mean, I don't think it matters the amount of water. 'Cause, I mean,
Yes, it would.
I feel like it could.
I don't know.
She could drown it. He could not give it enough. Oh yeah, it could.
Fair.
Shalia decides to be rebellious. It says 3 tablespoons of sugar. She does 4. I don't trust anyone doing this experiment. It's not a good one.
Doesn't matter.
It's just hard to judge his Benjamin Button. You can't just look at it and say, okay, this is the
Good old Benji.
But you said 12 or 2?
Benji Button.
12 or 2.
You said 12
I
students.
wish this push buttons.
Uh,
That'd be so good.
12 carnations, 2 students. Sorry, 12
It'll
carnations,
be
2
easier
students.
if it's 2 students because they can be beside each other.
They could, but they tell you in the problem that they
Oh, when they
got home, so you assume they went to their respective homes, unless they're siblings.
One of the two.
None of y'all are
What if they
siblings.
Went together.
But why would it say when they got home?
Wait, what?
It sounds like they each went on their own separate way.
Well, if you got home and did your homework at the same time another person did their homework.
Me and Alex can stay on the phone and talk about it the whole time. That does not mean me and Alex are really on the same page just because we're talking about it the whole time.
We're on like page 2.
Are you talking literally or metaphorically?
Like, metaphorically. Okay, so back to focus before me and Shalia got into semantics. We've got this equation, which seems great. And then the question was, but what are the 2 variables then? So we agree that, we don't agree, but sadly in this problem, they're saying maybe the amount of sugar given to the flower determines the freshness of the flower in hours.
And not the water person.
Yes, so we're specifically trying to measure the sugar affecting the freshness. So, if they're asking us, so we've done the least squares regression line, we have to interpret the slope. We've got to interpret that y-intercept. So the slope was 15.2. We need to interpret that. We've got to interpret that 181.2 as well. So, for the y-intercept, I'm going to say, what is the y-intercept telling you? How much sugar has been added?
0.
0. So if no sugar is added, the freshness will be 181.2, and is it it's in hours. And how do I know it's in hours? Because the problem said how many hours.
Should we say it will last that long?
Yes. So it should, and back to what Louise is saying of what is freshness. But theoretically, the freshness would last 181.2 hours if we added no sugar. So since it's a positive slope, does that mean our association is positive or negative?
Positive.
So it's a positive association. So if we wanted to go back to that R value, are we happy with it being positive 0.93 or should we change it to negative 0.93? So yeah, it's positive 0.93. So as we increase the sugar, what should happen to this flour's freshness?
Go stay longer, fresh.
Okay. So
Is that how flowers work?
I've never heard of adding sugar, but apparently in this experiment it does. So as the sugar increases
I guess like
by the stuff the fresh stuff you add to the water when you're supposed to make your flowers last, does it have sugar in it?
It might.
I don't know. That's a good question.
I mean, flowers make sugar. Would they just throw the sugar up and it's like?
I don't know. Apparently it's all, I don't know sciencey stuff. I don't do that.
Photosynthesis.
I know you were going to go there. I totally do that. Yeah, I totally do that. As the sugar increases by 1 tablespoon. That's not a tablespoon. I was going to say 1 unit, but it specifically said in the problem.
TDSP, right? Tablespoon?
Yeah, and it's supposed to be a capital T.
I don't
It is. If you want to spell out tablespoon, you can. I was trying to be fancy, and I knew the little thingy for it. Oh well.
I'm an F.
Phipps.
So if as the sugar increases, yeah, he's been playing on his phone this whole time. The freshness. Okay. Well, and I'm out of room. Increase
Exponential.
by 15.2 hours. And so I finally got my wording right, and so I could go fix what we did earlier, and we'll do that in just a second. So as the sugar increases by 1 tablespoon, the freshness will increase by 15.2 hours. So I need to go back and fix our number 2 above with the points for game one, where I went stupid for a second. I got my mind back together now.
So using this logic, I could just add an infinite amount of tablespoons of sugar and the flower will stay fresh forever.
Well, you think-
Clearly, and that's what our linear model is suggesting. So back to I doubt this experiment was going to be in with, because a linear model wouldn't be appropriate, because eventually there's a point where you've added too much sugar.
And there's a point where it's just sugar.
So you would think it would be more of a quadratic function, where eventually there's a point, and then after that a decrease.
You could just like add it progressively, like once a day, tablespoon of sugar.
In the flower?
That would make sense, but in their design, they didn't say they were doing that. They specifically said 3, 2, they did it 1 time.
Well, then also if you had an infinite amount of sugar, which you have to have an infinite amount of water.
And an infinite amount of flowers.
Well, just the one flower. If you had an infinite amount of water and an infinite amount of sugar, you'd have to have that proportion. Now you just put a bucket of sugar in the vase.
Now do we get
Now, I'm loving this debate, but you and I both know that the whole point was not for us to redesign the experiment. Eventually, so, I've tried to save you from things. Eventually, there are, my brain, there's a free response question that's going to take you longer than any other free response question on the exam, because it's called an experimental design, and you actually get to set up and design your own experiment in that. So you would get to design something like this, and you would then you would get to critique yourself. But in a given problem, you just got to roll with their information. You can't change it. But yes, we're eventually going to get so smart we can design our own experiment and not make this kind of a mistake. Okay, so I need to change my words. Yes, ma'am.
Would that ever not be a lot of except like it is in some algorithm?
No.
They will always just look at it like
There will always be a slope and a y-intercept, although I could see if it was a -1, maybe our y-intercept is so high. No, there'll always be one. It could be super high, but yeah, there'll always be one. Okay, so I need to go back and fix our words up here. I don't know if you have room somewhere, but in number 2, I was being blind. We were trying to interpret the slope of the football game. So what I should have said is as the Me too. I love stupid people interrupting me.
The girl in
We're out of it, I'm sorry. I can't, my brain is not.
Yeah, but it just ticks me off because it's only September 26th. We're only in chapter 3, and eventually there's 6 weeks of time where I've got to trust you turds to actually do math without me for 6 weeks so we can pass the exam in May. And whether or not they let me teach an AP class next year, yes, when you have a baby, you're out 6 weeks.
What?
I don't know. It's just like a set time. It's the set recovery time.
Oh,
It's like having a major surgery. I get a pass for 6 weeks.
Girl, after I what?
You're gonna give birth, Louise?
Huh?
You're gonna give birth?
Oh,
If you want to give birth for me, Louise, then I'll come back for 6 weeks. But
not how it
someone's got to give birth and stay home.
I don't exercise.
So somebody has to be that productive because eventually, whether or not they let me teach an AP class next year is reflecting on how y'all do on this thing. So, and then it's on how Sally did. And did she get her snack that day? Was she focused?
We can always put up some Khan
The
account.
quality of, I was really sad when they told me that I had 25 people, but I think I'd rather have 25 than a 13, because at 13 it's like, what if Sally's off that day? What if she's zoned out the way I feel like some of us are zoned out now? I really wish I had a room full, the way Ranillo has a room full. That way those zoned out, it would just be okay. But I don't, so it's not. So here we are.
Wait, what if you have a C-section? You're only out for 2
C-section, you're out longer, you're out 8 weeks.
Because you have to wait for the additional injury to heal too.
Yes.
I mean, it's not an additional injury.
That's good. Yeah, you could.
Additional recovery time
One
there.
way
Choose from
from
here.
out and one way
Work
from
for
out.
a year.
Yeah, but more than likely,
Exactly.
yes, but there's potential of it could be additional in that you could have tried the one way and failed and they had you. So there is potential.
Wait, solution. You use Skype lessons.
Well, I've considered that, but then that would still require you to, I don't know, pay even more attention to me, and I'm not even sitting here. How am I?
I paid.
Wait, who's the question?
We could FaceTime.
Yeah, that's what I thought of, is that y'all could just call me every day. I've thought of that. But then that would require,
Can we try?
so we're going to try that or something like that. I'm not going to not do stats for 6 weeks.
Are you gonna Skype
But
us?
again, it's only 2:57, which means we got 6 more minutes of this class, and that's 6 more minutes wasted today. And there's probably going to be a couple minutes wasted tomorrow. And then we spend time wasted during those 6 weeks. And you can see why Miss Compton's already super stressed about you, and it's only September 26th. I don't know how your other AP classes are going, but I feel like they're going so much better than this.
Oh, they're not.
No, you're
No, this is
right.
actually my better.
We're in chapter 2 in physics.
I feel like they're going so much faster, and they're so much more productive. And oh my God.
Don't forget the research.
Hey, is it recording?
And even worse, so this is my first year in AP, so I'm not really trained. So in that, not that I don't know stats, but I don't know this AP test. So there's some training date coming up in October. I'm gonna be out that day for the training day. It's not even out, and then I'm out one day because I gotta go to the doctor. Oh my God! I realize all this. No one watches my YouTube rants. If they did, they would have paid for me before now. I know.
If you posted them, they'll all know.
They can all know that I'm stressed. That's fine. And you know what? They can know all the things. That's fine. Oh, they all know now. I told all the people. Yeah, they all
There you
know.
go.
They all know it's a girl. They all know.
Can we just all cry now?
Oh my gosh. Oh Lord Jesus, help me now. Oh.
This is a false god.
I've got it. Let me fix the one thing and then I'll stop talking. Let me fix the one thing and then I'll stop talking. Okay, number 2. I said words and they were wrong. We need to fix my words. So when we interpreted the slope about that SEC football problem, we need to adjust that. So instead of it being, it needs to be as the wins increase. Ooh, as the points.
Sally, stop.
Sally, my God, get it together. Because sugar was the.
No, we're not on sugar, we're on points and wins.
Yeah, and winds was supposed to be the Y or the X.
Why?
Okay, so as the winds increase by 1,
Wait.
I need to adjust it. So we decided, I get my thoughts together.
Points increased by 0.
What are you changing?
I'm changing the words on number 2. So on our example, on the one at the bottom, we decided that the response, which we decided was the X or Y, response is X or Y,
X.
Why?
response is Y, explanatory is X. We decided that as the X increases, and then we talked about the Y increasing by that number. So that's what I'm going to say, as the X increases. So X was points. I had it right the first time. As the X increases, the Y's, which is the points, the winds, decrease by 0.44. So it should say, as the points increase by 1, the winds decrease by 0.44.
Wait, wouldn't it increase?
No, or was it a positive or negative?
Positive.
So increase, sorry. If you think she doesn't distract me too, she does. I worry about her too.
Sorry.
She does.
Kids don't laugh.
If you wanted me to point out who I'm worried about, I could.
Okay, see, this happened like every day in physics last year. I'm not even kidding. So you're fine. Yeah. Samantha, you were
Alex,
last year?
when you're in calculus, do y'all get more done than this?
Yeah.
Okay.
Yeah, but that's
subjective.
That's just.
Yeah.
Okay,
That's not
okay,
fair.
18 Kim.
Yeah, also, we're just gonna let this shit kind of goes, and we just, like, hold on for dear life.
That's who I want to be. That's what I want
It
to
doesn't help us, though, because I went through, like, a week without knowing how to do something. I had to look it up online and, like, learn how to do it myself.
do. But that's fine. I would get all this stuff
That
done.
was a wasted hour in that class.
Mackenzie, we're already supposed to be on chapter 4, and Giggle Monster means we still got to be on chapter 3 another day. My God. Lord help me.
Wait, so when are we
Jana, let me stop my recording.
Man.
When are we taking this